Salam sejahtera and good day, Doctor. I am Ong Hong Kai with metric number 286142. Today, Khong Jun, Jia Jun, and I would like to present our assignment 3. For this assignment, we obtain a dataset suitable for a prediction or classification model from UC Ivin Machine Learning Repository. Upon discussion, we have decided to use the Python programming language to recreate our model. The purpose of the model is to predict whether a customer will subscribe or not subscribe to a term deposit based on their demographic and banking related data. The objective of this model is the information obtained can help the bank in understanding the factors that influence customers' subscription decisions and improve their marketing strategies. By accurately predicting customers' subscriptions, the bank can allocate their resources effectively, target potential subscribers, and enhance their campaign success rate. The dataset we have chosen is the bank marketing dataset, which contains 45,211 records of customers and their associated features. The dataset includes the following input features: age, the age of the customer, which is numeric; job, the type of job the customer has, which is categorical; marital status, the marital status of the customers, categorical; education, the education level of the customer, categorical; default, whether the customer has credit in default, categorical; housing, whether the customer has a housing loan, categorical; loan, whether the customer has a personal loan, categorical; contact, the type of contact communication, which is categorical 2; month, the last contact month of the year, categorical; day of week, the last contact day of the week, categorical; duration, the last contact duration in seconds, which is numeric; campaign, the number of contacts performed during this campaign, numeric; p-days, the number of days that passed after the client was last contacted from a previous campaign, numeric; previous, the number of contacts performed before the campaign, numeric; and the last one, P outcome, the outcome of the previous marketing campaign, categorical. The target variable to predict is the subscription, whether the customer subscribed to a term deposit or not. This variable only has two outcomes, which are yes or no. The dataset consists of 45,211 records, and there are 15 input features along with the target variable, resulting in a total of 16 features. Next, I will proceed to the problem definition and insights. The problem we aim to solve is to build a classification model using logistic regression to predict whether a customer will subscribe to a term deposit based on their demographic and banking related data. By developing this model, we hope to gain insights into the factors that influence customers' subscription decisions and understand their significance in predicting subscription. Additionally, we aim to evaluate the performance of the logistic regression model using metrics such as accuracy, precision, recall, and F1 score. The insights that can be obtained from the data including identifying the most influential variables in determining subscription, understanding the relationship between the customer, demographics, and subscription decisions, and assessing the overall predictive power of the logistic regression model. These insights can assist the bank in refining their marketing strategies, improving customer targeting, and make informed decisions to enhance their campaign effectiveness and maximize subscription rates. That's all from me. Now I will pass the floor to the next presenter.
So the machine learning algorithm that we choose is linear logistic regression algorithm. So it is a supervised machine learning algorithm used for binary classification tasks where the goal is to predict the probability of an instance belonging to one of two classes, example, yes or no, or true or false. Despite its name, logistic regression is primarily used for classification, not regression. As for the characteristics of logistic regression algorithm, the first one is binary classification. It is specifically designed for binary classification tasks where the target variable has two classes only. Example, yes or no, true or false, or 0 or 1. It estimates the probability of an instance belonging to the positive class, which is 1, and predicts a class based on the chosen threshold. And the next one is linear decision boundary. It creates a linear decision boundary in the feature space to separate the two classes. The decision boundary is a hyperplane that separates the positive and negative instances. This linearity makes it easy to interpret the model's predictions and visualize its behavior. The next one is sigmoid activation function. The logistic regression model uses the sigmoid activation function, which maps the predicted values to probabilities between 0 and 1 only. This allows the model to produce well-calibrated probabilities, making it more interpretable than some other algorithms. Next one is interpretable coefficients. Logistic regression provides coefficients for each feature, representing the impact of that feature on the predicted probability of the positive class. Positive coefficients indicate a positive relationship with the positive class, while negative coefficients indicate a negative relationship. Next is the strengths of logistic regression algorithm. First one is interpretability. It is highly interpretable due to its linear nature and the sigmoid activation function. The coefficients provide insights into the influence of each feature on the target variable, making it easy to understand and explain the model's prediction. Next one is efficiency. Logistic regression is computationally efficient and requires relatively fewer resources compared to more complex algorithms. It is particularly useful when dealing with large data sets or situations with limited computational power. The third one is no assumption about feature distribution. Logistic regression does not assume any specific distribution for the features, making it robust in situations where the data might not be normally distributed. Next one is low risk of overfitting. Logistic regression is less prone to overfitting, especially when dealing with smaller datasets. Regularization techniques like L1 lasso and L2 reach can be applied to prevent overfitting and improve generalization. And the final one is baseline model. It serves as a good baseline model for binary classification tasks. It provides a straightforward comparison against more complex algorithms, helping to gauge the necessity of employing more sophisticated methods. So, how it works with the problem and data requirements. The first one is binary classification. The bank marketing dataset that we are used is typically used for binary classification tasks, where the objective is to predict whether a bank client will subscribe to a term deposit, yes or no. Logistic regression is specifically designed for these types of problems, making it a suitable choice for this dataset. Interpretability. The bank marketing dataset often requires interpretability to understand the factors that influence a client's decision to subscribe to a term deposit. Logistic regression provides interpretable coefficients for each feature, allowing us to analyze how each feature affects the likelihood of subscription. This is essential for the bank to make informed business decisions based on the model's prediction. The next one is efficiency. Logistic regression is computationally efficient and can handle large data sets without requiring excessive computational resources, like I said before. Given that banks often deal with a substantial number of clients and marketing data, logistic regression is a pragmatic choice due to its efficiency. Next one is linear decision boundary. It creates a linear decision boundary in the feature space to separate the two classes, which is subscribed and not subscribed, the term deposit. While the decision boundary might not capture complex relationships in the data, it can still be effective if the relationships are approximately linear. And then next one is feature importance. For the bank marketing dataset, understanding feature importance is valuable in identifying the most influential factors affecting a client's decision to subscribe. Logistic regression provides interpretable coefficients, allowing the bank to prioritize certain features in their marketing strategies. And the final one is baseline model. Logistic regression can serve as a good baseline model for the bank marketing dataset. As a straightforward and interpretable algorithm, it provides a benchmark against which more complex models can be compared. So I will pass it to the next presenter. Thank you.
So now we'll discuss about the model development to perform the logistic regression by using the Python. So for the first step, we will import all the necessary library from the Python into the workplace. And the next, we will loading the data, which is the bank marketing CSV, into the workplace. And the next step is select the data into input feature X and the target variable Y. And the next is we will perform a label encoding for the target variables. After that, we are performing the one-hot encoding for categorical variables. The categorical column in the input feature X are one hot encoder using column transformer and one hot encoder. The specific column in the categorical column are one hot encoder, while the remaining column are passed through without any transformation. The next step is defining the spread ratio. The risk of spread ratio is defined, indicating the proportion of the data that will be used for testing. For example, we will spread the ratio into 10%, 20%, 30%, 40%, 50%, 60%, 70%, 80%, and finally is 90% of the data in the data set that we use for the testing. And the next step is training and evaluation for model. For each spread ratio in the spread ratio variable list, the data is spread into training and testing set using train test spread. A logistic regression model is created and trained on the training data. Then prediction are meeting on the testing set and the various performance metric and the various performance metric such as the accuracy, precision, recall, effort score, and the confusion metric are calculated using the scattered run function. So after that, we will printing the performance metric. The performance metric are printed for each spread ratio, including the spread ratio itself, accuracy, precision, recall, F1 score, error rate, and the confusion metrics. So now I'm going to explain about the rule of accuracy, precision, recall, error rate, and finally is the F1 score. So firstly is the accuracy represent the proportion of correct prediction out of the total number of prediction. It measures the overall correctness of the model. However, it can be misleading if the dataset is imbalanced, as it may yet higher accuracy even if the model performs poorly on the minority classes. Second, the precision measures the proportion of true positive prediction out of the total predicted positive. It focuses on the correctness of the positive prediction. A higher precision indicates a lower false positive rate, meaning that the model make a few incorrectly positive predictions. And the thirdly is a recall, also known as the sensitivity or true positive rate, measure the proportion of true positive prediction out of the total actual positive. It is focused on the model's ability to correctly identify the positive instances. A higher recall indicates a lower false negative rate, meaning that the model captures a largest proportion of positive instances. The next is the rule of the error rate in the model evaluation is to provide an inductive understanding of the model's accuracy by quantifying the percentage of incorrect prediction. A lower error rate indicates a better performance, as it means that the model is making fewer mistakes and a higher level of accuracy. Finally is the F1 score is a harmonic mean of precision and the recall. It provides a balanced measure of the model's performance considering the both precision and the recall. F1 score is useful when the dataset is imbalanced or when the both false positive and false negative are important. So for this table, we can see that the result of the various performance metric, including the accuracy, precision, recall, error rate, F1 measure from the different spread ratio. After that, we will compare the different fraud ratio and identify the best performing. So the best model for the accuracy metric is 80% for training, 20% for testing. The accuracy of the model is 0.894, which means that it correctly predicts the outcome for approximately 89.4% of the instances in the testing set. After that, the best model for precision is 90% for training and 10% for testing. The precision of 0.61 indicates that when the model predicts a positive outcome, it can be correctly predicted around 61% of the time. This metric is useful in situations where the cost of false positive is higher and we want to minimize it in. So the third one is the recall, and the best model is 80% for training, 20% for testing. The recall, also known as sensitivity or true positive rate of 0.271, means that the model correctly identifies around 27.1% of the actual positive instances. It can be measured of how well the model can capture the positive instances. So the next one is a best model of the error rate metric is 80% for training, 20% for testing. The error rate of 0.106 indicates the model misclassified approximately 10.6% of the instances in the testing set. It can be complement of accuracy and represent the proportional of misclassifying instances. So the finally is the F1 measure. The best model for the F1 measure is 80% for training, 20% for testing. The F1 measure of 0.374 combines precision and recall into a single matrix. It provides a balanced measure of the model performance by considering the both false positive and false negative. A higher false one score indicates the better overall performance. So generally, a spread ratio of 0.8, which is the 80% for training, 20% for testing, show that the relatively higher precision recall F1 score and a lower error rate compared to the other spread ratio. So this can be considered that the best performance of the fraud ratio is the 80% of training, 20% of testing spread ratio. So now I will explain about the insight on the performance of the model. Firstly, the model achieved an accuracy ranging from approximately 88.6% to 89.4% across different spread ratio. This indicates the model is able to classify the majority of the instances correctly. Second, the precision range from approximately 58.2% to 61%. This metric measures the proportion of true positive prediction out of the total positive prediction. Higher precision value indicate a lower rate of false positive. Thirdly, the recall range from approximately 20.7% to 27.1%. This metric measures the proportion of true positive prediction out of the actual positive instances. Higher recall value indicate a lower rate of false negative. So the next is the error rate. The error rate range from approximately 10.6% to 11.4%. This metric represents the proportion of misclassified instances, and the lower error rate indicates a better model performance. And finally, the F1 score range from approximately 0.31 to 0.37. This metric combines the precision and the recall into a single value and provide a balanced measure of the model's performance. Higher F1 score indicate a better overall performance. So now I'm going to explain the limitation or challenges for the models. Firstly is an imbalanced dataset. This means that the dataset used for training and evaluation may have imbalanced class distribution, where one class including yes or no is significantly more prevalent than the others. This can affect the model's ability to accurately predict the minority class and may result in biased performance metrics. Second, the data preprocessing. This means that the model applies a hot encoding to categorical variable and label encoding to the target variables. However, there may be other preprocessing techniques that could be enhance the model's performance, including the scattering numerical variable or exploring different encoding strategy. And finally is the hyperparameter tuning. This means that the logistic regression model used in this implementation is a default model with the default hyperparameters. Tuning the hyperparameters of the model, including the regularization parameters, could be potentially improve the performance of the models.